All right, imagine for a second that you're a flight trajectory engineer. You're working on a high-stakes space mission. You've literally spent years preparing for this exact moment. Millions, maybe billions of dollars are on the line. The rocket is launching, and you are sitting there calculating the precise orbital insertion angle required to safely dock with the space station. Now, you do all the complex calculus perfectly. The algebra, completely flawless. But you make one tiny, seemingly insignificant oversight. Your system was set to degrees instead of radians. So what happens? Well, you don't just miss the target. Your multi-million-dollar ship completely crashes into the vacuum of space. Mission failed. Okay, let's bring this back down to earth, because sitting your Cambridge mathematics exams, and we're talking about syllabus codes 0580, 0606, 4024, 4037, or 4040, is actually exactly like that space mission. Honestly, mathematical precision is life or death for your final grade. The difference between securing a standard B and an elite A star often comes down to having zero margin for error in your foundational setups. So today, we're going to dive deep into the ultimate trajectory miscalculation that completely crashes thousands of Cambridge exam papers every single year. Welcome to the explainer that is absolutely going to bulletproof your exam strategy.
Here is our mission briefing for today's explainer. First up, we've got the challenge, where we'll identify exactly where students crash and burn. Second, we're going to establish the Radian core principles. Third, we'll break down the technical methodology, what examiners are actually looking for. Fourth, we'll review some urgent mission control warnings straight from the principal examiner reports. And finally, we'll wrap up with the final strategy, giving you the exact answering system you need to guarantee top marks. Let's not waste any time. All right, Section 1, the challenge. Let's look at exactly where students fail and crash their missions right out of the gate. So, picture a typical past paper question. Let's say it's from syllabus 0606. You are asked to find the exact area under a curve, and the function involves a trigonometric element. Maybe you're integrating sine of x over a specific interval. The pressure is completely on. The clock in the exam hall is ticking, and the command word clearly says show that, or maybe calculate the exact value. This scenario brilliantly illustrates the two absolute most common ways to fail the mission. On one side, we have our first student type. Let's call him Alex. Now, Alex is a hard worker for sure. Alex has memorized every single trigonometric identity and integration rule in the book. But when it comes to the exam, Alex overloads the page with raw math facts and zero analytical structure. Just literally dumps formulas onto the page, hoping the examiner will magically piece them together. The result? A page completely covered in red pen marks. Why? Because Cambridge isn't just testing your memory. They are testing your logical progression. Then on the flip side, we have Sam. Sam is quick, but a little careless. Sam rushes straight into the calculation and completely misses the critical command word requirements. The question specifically said exact value, but Sam spits out a decimal. And even worse, Sam falls into the ultimate trap, leaving the calculator in the wrong mode. This is exactly why these types of answers receive brutal red pen marks from examiners. They just completely lack the structured reasoning that academic benchmarks require.
So what does this all mean? It means we need an absolute, non-negotiable rule to prevent this kind of disaster. Burn this into your memory right now. The absolute rule. For trigonometric functions involving calculus, so integration or differentiation, angles are always in radians. Let me actually repeat that because this is literally the core navigational rule for your entire exam mission. In Cambridge Additional Mathematics, if you are integrating or differentiating a trigonometric function, your angles must be in radians. No exceptions. Why? Well, because the standard derivatives of sine and cosine are derived using the fundamental assumption that the angle is measured in radians. If you use degrees, the math just fundamentally breaks. It is the real-world equivalent of sending your rocket coordinates in inches when the navigation computer is reading in light years. It's a catastrophic failure. And examiners consistently report this as one of the most frequent reasons students drop from an A star to a B.
Moving right along to Section 2, Radian core principles. Let's get into the theoretical framework. You see, top-performing students don't just memorize rules. They exhibit a deeply connected conceptual understanding that is completely transferable to any unfamiliar context the exam throws at them. Let's see how this builds into an actual actionable strategy. Introducing the Peel framework. Point, evidence, explanation, link. Now, I know what you might be thinking. Wait a second. Isn't Peel for English essays? Absolutely not. This is the secret architectural structure that top math students use to hit all those higher order assessment objectives. Before we continue breaking this down, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, so in advanced mathematics, the Peel framework works exactly like this. Point. You state the mathematical principle you are applying. For instance, you would write, to find the area, I must integrate the trig function ensuring angles are in radians. Evidence. This is where you extract the specific data or limits right from the question. Explanation. This is your step-by-step algorithmic working, the algebra, the calculus showing every single logical step with clear, unmistakable notation. And finally, link. You tie your final numerical answer directly back to what the command word actually asked for. If it asked for a coordinate, your link is stating that final XY pair crystal clearly.
Now, I have a challenge for you. Think about everything we just discussed. I'm going to give you a 30-second mental timer. Imagine you're looking at two different student answers. Which one perfectly follows the Peel framework? You really need to look closely at how they define their terms and present their logic. Take a few seconds, analyze the steps, observe how the physical layout on the page impacts the clarity of the reasoning. All right, time is up. If you realize that the winning answer is the one that doesn't just spit out a final number, you are spot on. A perfect answer justifies the approach, explicitly states the assumption of using radians, shows the calculation cleanly, and links it right back to the original context. That, my friends, is exactly how you secure maximum marks.
On to Section 3, Technical Exam Methodology. This is our execution strategy.
We've talked theory, so now let's talk execution. Here is your strict step-by-step procedural flight manual for tackling those incredibly complex Cambridge syllabus questions. This is where you transform from a candidate who just does math into a candidate who engineers a perfect response. Step 1. Deconstruct the question. Highlight those command words. Are you evaluating, showing, or solving? Know the difference. Step 2. Extract relevant data. Pull the numbers, the functions, and the limits out of the text block and get them into your clean workspace. Step 3. Select the analytical framework. Ask yourself, what topic actually is this? Oh, it's trig integration? Boom, framework selected, the Radians rule applies. Step 4, execute with clear notation. I cannot stress this enough. This is vital. Do not drop your dx when you're integrating. Do not forget your integral signs. Use proper headings, correct terminology, appropriate formats, and clear annotation. This level of systematic analysis is exactly what the assessment framework is prioritizing. And honestly, this brilliantly illustrates why Step 4 is so incredibly critical. Let's talk about the method mark strategy. In Cambridge Additional Mathematics, marks are awarded for the analytical process and the logical reasoning, not just the final destination. Think about it. You could make a tiny, silly arithmetic error on the very last line of a massive 7-mark question. If your method is just hidden in your head or scribbled illegibly in the margins, you lose all 7 marks. It's devastating. But if you have laid out your logical reasoning, shown your clear notation, explicitly stated your limits, and properly applied the Radian rules, you might actually still walk away with 6 out of 7 marks because of the method mark strategy. It's a huge safety net. The examiner needs to see your evaluation of alternative approaches and your justified mathematical steps. Show your work, always. Stop scrolling. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSEs to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to acetheexams_IGCS and turn on all notifications so you never miss our weekly exam strategy sessions.
All right, welcome back. Let's dive into Section 4, Mission Control Workshop. This is the interactive phase. It is time to put your analytical skills to the absolute test. Imagine a complex mathematics source right in front of you. A rigorous data table showing various trigonometric relationships and strict formatting conventions. I'm starting a 60-second visual countdown for you to mentally scan it and extract the critical data. Get ready. Your 60 seconds starts now. I want you to mentally scan the rows. Look at the inputs. Look at the outputs. Try to identify the core trend and interpret the relationships hidden within this data. Notice how the values behave when the input crosses, say, the pi/2 threshold. Observe the strict presentation of the information, the clear annotations, the proper headings. Data interpretation skills in these advanced math papers are just critical. You absolutely must be able to extract relationships from text and tables and draw solid evidence-based conclusions.
If you spotted that the outputs only align with standard calculus derivatives when the input column is explicitly defined in radians, then congratulations. Your data extraction skills are exactly where they need to be for a top grade. Let's take all these insights and see how they build right into our next critical concept, the magic number 3. We are shifting into critical evaluation mode by revealing the top 3 catastrophic mistakes taken directly from the Cambridge Principal Examiner reports. These are the mission hazards that take out thousands of candidates every single year.
So, here are your primary mission hazards. Hazard number 1, formatting errors, and specifically, forgetting to switch to radians for trigonometric calculus. I know we've hammered this home today, but examiners note this as a constant, massive source of lost marks. Hazard number 2, poor presentation and annotation. When examiners simply cannot follow your logic because your working is just scattered randomly across the page, they physically cannot award you method marks. Your descriptive, analytical, and evaluative levels must be clearly visible. Hazard number 3, answers lacking specific context. Say you find the value of x, but you don't evaluate its actual effect on the conclusion. Does that x value even make sense in the context of the physical area you are trying to calculate? Ignoring these strict conventions leads to just massive point loss.
I want you to treat this quote as an urgent, high-priority transmission straight from mission control. A principal examiner literally wrote, "Candidates consistently confuse key terminology. Always define terms before using them in extended responses." This is huge. Evaluation of evidence quality requires identifying limitations, the assumptions you've made, and alternative interpretations. If you are introducing a brand new variable, you have to state what it is. If you are assuming a certain domain for a function, you must define it explicitly before drawing your conclusion. This level of professional academic skill is exactly what separates the top percentile of students from the rest of the pack.
Let's execute our final interactive speed drill. Imagine you're looking at a mathematically flawed assumption regarding a trig limit. You have 30 seconds. The challenge is to write one perfect, structured paragraph using that Peel framework we talked about to identify and rectify the mathematical flaw. You need to state your point clearly, bring in your evidence directly from the equation, explain the breakdown in logic, did they maybe use degrees instead of radians, and finally, link it to the correct, fully evaluated conclusion. Being able to quickly and accurately articulate your mathematical reasoning is practically a superpower when you're sitting in the exam hall.
We've made it to Section 5, the final strategy, the final system.
You've navigated the hazards, you understand the core principles, and your trajectory is totally locked in. Let's look at the ultimate cheat sheet and recap the mathematics answering system that gets your progress bar all the way to 100% mark potential. Here are the 3 absolute rules that guarantee top marks on your Cambridge papers. Rule 1, command word decoding. You must always know exactly what action the question is demanding from you. Rule 2, Peel framework application. Structure your logical reasoning so clearly that the examiner literally has no choice but to award you full method marks. Rule 3, time management matrix. Execute your procedural framework efficiently so you actually have time at the end to check your format, especially verifying that your calculator is in radians for trig calculus. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to at acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here. Keep studying, stay structured, and I will see you in the next explainer.